This lesson, we are going to be talking about continuity of the transcendental functions. These are the transcendental functions. So just a basic idea that it says the following functions are continuous on all the points of their domain. So some of them have domain issues, but the ones, the values, the graph within those domains are all not going to have any breaks in them. Okay, so here's what I mean by that. Sines and cosines, a sine curve, right? It's a wave. It has no domain issues. Cosine has a wave, has no domain issues, but tangent has a domain issue. So tangent kind of has this look to it, but within the domain, there's no breaks or any problems within from asymptote to asymptote, right? So that's all that means. And so inverses also have asymptotes in it. These reciprocals have asymptotes in it, but everything within from asymptote to asymptote is going to be totally continuous, right? Exponentials don't have domain issues, and so that's continuous everywhere. Logs do. Remember what a log is in general. Our log graph kind of looks like that, but has a domain issue. So our logs have to be, at least if we don't adjust anything on them, whether it's a natural log or a log of any kind of a base, is we're looking at something that needs to be greater than 0, right? So x would need to be greater than 0. You can't log 0. And then trig functions, the tangent has its own kind of thing. So in an inverse is as long as if f of x is continuous on whatever interval we're talking about and has an inverse, then its inverse is also going to be continuous. Okay, so let's do 2 examples with this a little bit. So it says, first off, we're going to analyze the limits after determining the continuity of the functions involved. So is there a break in this graph? Is there potential for this domain, this denominator to be 0? Right? Maybe. I don't know. So let's plug it in first. So let's plug in x equals 0. So if we plug this in, this really means cosine of 0 squared minus 1 over cosine of 0 minus 1. Okay, so that's our math that we're looking to do. Cosine of 0 is 1. And if you don't remember, I think of a cosine graph like this. And there's your cosine of 0. So cosine of 0 is 1 that you're going to square minus 1 over 1 minus 1. And so that is going to be 0 over 0, which probably means we have a hole. So it is a domain problem. However, if it's a hole, the limit's going to exist. So I'm going to continue. So limit's going to exist. But since I have a feeling that this is going to be a hole, that means that this is probably going to be able to factor and cancel. This cosine minus 1 is probably going to have another cosine minus 1 on the top that's going to factor. Right? I kind of have a feel for what's about to happen. So this thing is going to be factoring as if it was an x squared minus 1, which is going to factor in an x plus 1, x minus 1. It's a difference of squares, the trig. Oops. So it's like an x squared minus 1. It's going to be an x plus 1, x minus 1. So just because it has a cosine on it doesn't mean we treat it any different. So that's going to be a cosine x plus 1, cosine x minus 1. And then we have a cosine x minus 1. There's the problem canceling out. That's when we plugged in 0. That's where we get our 0 over 0. And so now we're really going to be doing the limit as x approaches 0, cosine x plus 1. And so we plug it in. We can drop our limit symbol because we're plugging it in. So we're doing cosine of 0 plus 1. And cosine of 0 is 1. 1 plus 1 is going to give us 2. So that is our limit as our graph is approaching 0. Right? And then if we do this one's got a lot of little pieces to it. So we got to figure out, can we plug in 1? We can just analyze this before we even deal with the inverse tangent thing. The inverse tangent of 1 is going to be a 45-degree angle, so pi over 4. So we're going to be okay on that one. But this, doing the limit on this might be a bit of a problem. So we'll see. So let's dive into this. First off, we have ourselves a root, and it is an even root. So even root, that means that this inside piece here needs to be greater than or equal to 0. That's just, I'm not even worried about the natural log, just whatever you get after you plug it in, that thing has to be positive. Okay, so we'll come back and revisit that in a second. So here's our problem. A lot of little layers to it. So let's start on the inside. The natural log of x. The natural log of x, its domain is from 0 to infinity. You can't log a positive, or you can't log a negative, and you can't log 0. So 0 to infinity, right? And then if we take a look at this fourth root in general, let's ignore the natural log piece of it for a second. Then we'll combine the two. Its domain is 0. We can fourth root a 0. We can square root a 0 to infinity. Okay, so if you combine them, so far, the not including the 0 kind of kicks out the including a 0. So right now we're kind of sitting at a 0 to infinity. However, the natural log has has a problem to it. It's negative when x is between 0 and 1. All right, and let me show you the graph to help remember that. So here's 1. So if that's 1, anything between 0 and 1 is going to get you a negative value, and that's actually going to cause a problem. Right? So we have to tweak this because of the fact that the natural log has a domain problem, but then you have another layer of domain problem is this thing can create negative values and that we don't want. Right? And so our overall domain on this thing, let's be squiggly, is this fourth root of the natural log. That piece's domain is from 1 to 0, infinity, sorry. You can natural log 1. If you natural log 1, you get a 0, and you can fourth root that. But that's it. Like, you got to go bigger than that in order for it to be okay. So if we do the limit, let's just take a look, continue to take a look at this side. As x equals 1, if we do the limit from the left of this fourth root, so the left side of 1 doesn't exist. So instantly we're trying to see if these two things were going to equal each other. But this piece right there does not exist. There is no left side of graph. So it doesn't matter what this is. Does not. So the trig piece in this does not matter either. This is the one that has the issue. This one doesn't have an issue, at least at 1. Right? So overall, what is our limit? As x approaches 1 of that function, it does not exist. A lot of little pieces to it. You really kind of have to dive deep on some of these more complicated ones and really take a look at what the left side's got going on and what the right side guys got going on. Take a look at individual pieces, maybe not the overall thing. And that'll help you get your domain, or that'll help you get your limit.